A very good evening to all. Welcome to 6th day 12th technical session of 6th day online faculty development program on electric vehicle and charging station technology for sustainable development sponsored by AICTE ATAL. And our resource person for this season is Dr. Subhra Jyoti Mondal sir. On behalf of the organizing team, I welcome you sir in our today's technical session. Before you start your expert lecture, I would like to share a short biography of you to the participants. Dr. Subhra Jyoti Mondal sir is working as a principal AI engineer at Advanced AI and Insight at JSK. He led the design and implementation of AI-driven solutions for JSK Global Supply Chain (GSC), especially in computer vision and Gen AI, with over 14 years of experience in AI, machine learning, natural language processing, and computer vision, coupled with a PhD in quantum physics and bachelor and master degree in computer science. He poses a robust foundation NLP, Gen AI, and computer vision domains. He leverages cutting-edge techniques and tools like TensorFlow, PyTorch, and OpenCV to develop impactful solutions that enhance healthcare delivery efficiency. He is currently pioneering the development of a computer vision solutions for monitoring vaccine production environments and exploring the potential for AI in healthcare. Additionally, he has introduced Gen AI capabilities to optimize the global supply chain processes at JSK. Throughout his career, he has successfully managed numerous AI and NPL project implemented solutions on the Microsoft Azure platform and established scalable models development process. He is to apply his expertise in AI, computer vision, and NLP to create innovative solutions that revolutionize healthcare delivery and outcomes. With this, I would request our expert, Dr. Subhra Jyoti Mondal sir, to kindly enlighten us with his word of wisdom. Sir, please, you can continue.
Thank you, Kuzvi. Let me share my screen. I hope my screen is visible, right?
Yes, sir, it is visible.
Visible. Okay. Thank you all. Today I'm going to present machine learning in EV and automobile industry. Mm, just quickly, so already Khushbu has introduced me. So just quick look about me. I have 15 years of experience in the research, machine learning and computer vision. Currently, I am associated with the GSK as a GlaxoSmithKline is a pharmaceutical company. Here, my role is to create a AIML solution for the vaccine domain, especially for the drug discovery, vaccine manufacturing, and the quality. Mostly, I work here in the computer vision related project where I generally create a computer vision model to improve the vaccine delivery, to improve the quality, to improve the smart manufacturing. My background from the BTech and MTech I have done BTech and MTech I have done in computer science, and then I did PhD in the quantum physics. Mostly my research interest in the currently in the computer vision. I am tapped. So my company is already tapped with the Microsoft, Google. So generally we do the research in collaboration. So today mostly I'm going to talk about the machine learning in sorry.
Steve.
Okay. So if you are not talking, could you please mute? Yeah. So today mostly I'll talk about the machine learning in automobile industry, and I'll look into the self-driving car also. So mostly, if you see the content, mostly I'll be focusing on the introduction of the machine learning for the self-drive car, core machine learning technology which you are using for the smart manufacturing, automobile industry, or EV industry, and then some real world implementation on case studies where the machine learning is already implemented into the automobile and the EV industry, and what are the future scope we can work into the to improve the EV industry and the automobile industry. So before going to that, I would like to give a quick, just a recap or a quick overview what is machine learning. So basically, machine learning is a part of the artificial intelligence. If you see, the artificial intelligence is a superset, machine learning is a subset. So we have a machine learning, we have a statistical modeling, we have a deep learning, and then we have a GNI. So all this is part of the artificial intelligence. So what is machine learning? Machine learning is a mathematical model. Basically, they take the input or they learn from the data and then create a model, and that model we can use into various of various of work, automate various of work to automate, and then we deploy this model into production, so that same kind of when the same kind of data comes, that model do the inferencing. So if you see what are the steps generally follow for the create any machine learning model, the first one is the data. So data is very important. So basically whatever the data will give as a input as a training, model will learn based on the data. So data is a high important. Then second is the training. So how the machine learning model is training. So we have a lot of algorithm machine learning model like the neural network, LSTM or onion. So which algorithm you are using and how you are training the data. So that the second part is the training. Third is the model development. After training is done, generally you'll create the model and do the model evaluation. And the once model is ready, then you will deploy the model into the production or into through API where the inferencing can happen. Inferencing means the new data will come and model will act based on the training data. If you see the life cycle generally will follow in the industry, starting from the, so basically first you'll get the business problem. So business generally tell this is my problem, this is my pain point. If you solve this and if you automate this, then this kind of business value will create. So first we analyze the business problem, then we ask for the data from the business. So if it is the manufacturing, we'll get the manufacturing data from lot of sensor. If it is a retail, to generally get the retail data. If it is a EV, so all the sensor data will go. So the first we'll collect the data, then we'll quickly do the exploratory data analysis to check the data quality. And then if the annotation is required, we'll do the annotation. If the pre-processing is required, we'll do the pre-processing, and then we'll start the building on the machine learning model. So during this data exploratory data analysis, and that time we try to understand which kind of algorithm will fit. So is it the classification problem, is it the object detection problem, is it the segmentation problem, it is the prediction problem. So that generally try to find out from that. Also from the business problem also we can understand, we basically try to understand what kind of algorithm will fit. So then we choose the algorithm. So in each group, right, if it is a classification problem, we have a lot of classification algorithm. If it is object detection problem, we have a lot of object detection algorithm. So basically we test all algorithm, or we select based on the experience and based on the research paper, we select the algorithm, we test on the data, and based on based on the output, so whatever that which algorithm is giving the best output, that algorithm generally will finalize. And then we do the continuous evaluation of this algorithm. So basically when you segregate the data, you create the train data, test data, and the validation data. So validation data is totally unseen data, and that data generally create manually, and in industry it's called a gold standard data, here where all my scenarios would be covered. So when I test, when the any model will pass through the validation data, then that model will put into the production. So in the production we'll put the model, so that time the model is live and the real time data is coming, and continuously we have a model monitoring report. So continuously generally we'll monitor this model performance. Is there any model drift, is there any data drift? So those things we generally monitor in the model monitoring. There is a lot of tools available or technique available for model monitoring. Generally, we'll use MLOps technique. We have a weight and bias. We have a Azure model monitoring. We have a Databricks model monitoring. And then if the model is performing down, then we generally do the model retraining. So this is the complete step generally will follow any kind of machine learning tech. So next I'll talk about the machine learning in automobile industry. So if you see, the automobile industry start from the manufacturing. So in the currently in the lab, there is a lot of automation and happen. So currently, if you see the from the market analysis, what are the demand of the market? Generally, we will do a lot of machine learning algorithm to the market analysis. In the current manufacturing, the design and manufacturing generally use the machine learning. So I'm not going to details. So in the manufacturing is all we have now the robotics lab in any kind of industry like the automobile or our healthcare. So all these industry have a now robotic lab, and that robotic lab act based on the AI algorithm output. Then the quality control also we do the through the machine learning. Like for my organization, when I do the quality control, when I'm checking the environment is clean or not. So that time I'm using the object detection model, basically collecting all the sample from the lab and putting into the petri and checking is there any bacteria and molds are there. For the quality here also, when we'll do the like the paint quality, when we'll do the driving quality, so all this data basically will gather from the sensor and do the quality control. And then passenger experience. So still in this passenger experience, there is a lot of automation is done. So currently from the your driving seat, from the memory seat and the driving comfort, like so generally in the car try to based on the sensor try to understand what is the driving experience, or what is the person who is driving, what is their driving status. That also currently a lot of research is happening where we can capture the emotion or capture the driver is stressed or not, or driver is sleeping or not. These kind of information we try to get from the sensor, from the camera, and try to analyze some object detection algorithm or try to analyze these things. So this is also there. Then driving assistant, this is the ADAS technology. Anyways, this is currently available in India also, and the outside is already available long time ago. So ADAS basically try to find it's a semi-auto drive car. When there is any instant try to get the brake, it predict the lanes, it can change the lane. So that is also happening from the ADAS. And then totally for the self-driving cars, which is not available in India, so that is available in the outside in the country like US and UK. So that the self-driving car is fully automated car where the lot of cameras installed in the car, and continuously it is taking images, taking the video, convert it into the frame, analysis those images, and take the continuously decision. So that everything is happening into the computer vision and the video analytics in the current industry. So if you see what are the major problem or major things where we are using the machine learning for the EV industry. So the previous slide I talk about the total automobile industry, not the specific any EV or the petrol car or diesel car. Basically, the last slide I talked about the overall automobile. So this slide is especially the where we are using the machine learning in the EV industry. The first is the efficiency optimization. So we are getting data from the sensor, and through the machine learning and the deep learning algorithms, we are trying to predict and optimize the car value, or the optimize the we are optimizing the route. We are optimizing also the GPS is also one kind of automation or one kind of machine learning technique where real-time data we are getting, and we are based on the current the the road condition, we are suggesting to the user, okay, so you can change the road. So these efficiency optimization, we have put all the machine learning algorithm to do the optimization. Second is the major thing is the battery management. So still all the companies are working on the battery management. Still we are not good into the battery management. So currently whatever the all EV car is we are seeing that just in India, it's a 2 or 3 years old EV car is running. But when we have to change the battery, that time is a huge cost will come. So the battery management is essential thing. And I think there's a lot of research is required in the battery management, because all what you are using the lithium battery, and when you are doing the full charge, suppose from A to B, you are doing the full charge, and it's showing it will go for 200 kilometers. But actually it will not go for 200 kilometers. So a lot of other thing is factor. So when in actual scenario, what is the road condition, what is the traffic condition, is there some vehicle is already stuck, so my car is stuck. So that time also a lot of battery consuming will happening. So those things we need to do a lot of optimization of the battery. Also, we need a lot of real-time prediction when real-time signal prediction. So that is also required. The battery management is key thing where I think the industry should focus on the more work. Then the predictive maintenance. So when the all the so in the nowadays all the car is the not a mechanical car, all car, it's all the car is electrical car. So there in each car there's a lot of sensor. So the predictive maintenance means so that when the all the car is when the car is running into the road, and every every day generating the data, and based on the data we can predict, okay, so now the service is required, now this part is going to be damaged, this part should be changed. So these kind of predictive maintenance we can use, we are using in the machine learning, and there is a lot of improvement we can do through the machine learning and deep learning algorithm. And then the continuous improvement of the autonomous driving. So if it is a road is very empty and the traffic, everybody is using maintaining the traffic rules, then the automatic the self-driving car is good. Self-driving car can work, but in current the India situation, the self-driving car is not a practical scenario, because here the road condition is very bad. Generally we don't follow the traffic rules, and there is a lot of population here. So those things still we need to work on, especially in the quick response in the, so especially in the computer vision and the sensor and the quick action part. So that still is research is ongoing, and every so these Tesla and others or the self-driving car company, they are still evolving, they are still researching and evolving. So now I'll talk about the what are the key algorithms generally used for the self-driving car. So this slide is basically the evolution of the self-driving car. So earlier days when the car was totally mechanical car, and slowly we started into the from mechanical to converted into the electrical car, where means the we have lot of sensor and we're getting the data from the sensor, and car is acting, and all the all the maintenance what are doing currently analysis the car. So currently we are doing through the electrical. So if you go to the garage, they'll in the steering there is a one USB port, so they'll put the laptop and they'll do the health checker. In this health checker they get to know what are the condition in the car. So that is now we converted. Then in 2024 Google has started the first their project called Waymo project. So that is the first self-drive car project they have started. But Tesla come up, and now the Tesla in the top of the markets, and Tesla is already created the self-driving car, and that self-driving car is already running into almost 3 to 4 years in the US and UK market. So currently we are in the self-driving car, but all in the first world country, not in the second and third world country. So important machine learning for autonomous car. One is the enhancing safety. So that is more important when you are so every machine learning algorithm work based on the probability theory. So all this decision is taking based on the probability theory, and the decision is accurate, sometimes 80%, sometimes 90% accurate, 80% accurate, 85% accurate, or 99% accurate. So still there is a error is there. So that you have to work a lot. And the safety is major thing. Suppose the car seeing there is an object, and the car predict in the road there is an object, but somehow because of some sensor issue or because of the object detection model issue, car suppose didn't predict the object and the accident happened. So that is the major thing, the enhancing safety. So we have to work in lot the safety. So safety is a key feature. Second is the user experience. So when you're driving the autonomous car, what is the user? So basically, in the autonomous car, self-driving car, if you I don't know if you see the Tesla or not. So in the Tesla car, there so there is a lot of camera outside, and a lot of sensor also inside, and the camera also inside. They're continuously taking feedback from the user how they're driving. And suppose in the self-driving car also you have an option and steering, so you can control the steering. You have option for brake, you have a option for brake for any kind of emergency brake. So based on user feedback, cars still try to learn. So that is the user experience they are gathering. So there is a lot of work we can do and industry is doing in the user experience. And then next is the basically navigation, the map part, and the map is now this India also, there's a lot of improvement. Now, if you go to any A to B place, any type of Google Map or Apple Map, they can show the direction. If there is any kind of accident happen, that also map can give the information. So there is an accident happen. If there is a roadblock, that is also give the information. But sometime India, we generally frequently do the changing the road. So sometimes there is a one lane is open, generally close the lane. So those quick real times still we are lagging in the India point of view. So there is a bridge is under construction. Sometimes the our map is not able to understand or not able to identify these things because of the user input. So user input is less here. But in all the first world countries, the Google Map is working fully, um, almost 98% or 99% efficient. So what are the deep learning algorithm involved for self-driving car? One is the basically for the object detection. So that is the main algorithm generally used for the any kind of self-driving car. So there is a lot of object detection algorithm available. Like the from Meta, you have a detection tool. From EOLO, there is a various EOLO object detection algorithm. And after object detection, then I will check the classification. So object detection algorithm generally try to find out is there any object is there now, which kind of object. Then we'll move into the another algorithm called the classification. In the classification, we have a CNN based classification algorithm. We have a GenAI based classification algorithm that can be used. Then sensor data processing. So all the self-driving car try to get information from the sensor. Sensor means all the sensor which is already fitted in the car. So that the real time they are taking this data, and all these machine learning models, small model, they have deployed into the car, and every time is taking the prediction. Every time is giving the prediction. So these sensor data processing also we are doing. So the key major thing generally generally we use in the machine learning generally used for the self-driving car. One is the neural network based application, and then image and video recognition. Anyways, for the self-driving car, all that depends on the image and video, and a lot of the sensor which is already there in the car. So those data generally we analysis. So as I mentioned, core machine learning algorithm generally used for the any self-driving car. The first one is object detection. So that there is a various types of machine learning algorithm available for object detection. So when you are driving the car into the day condition, so here the object is looking different. When the driving in the car in the low light conditions, where the object is different. So lot of pre-processing is required, and also a lot of sensor is available that try to find out, okay, is it day condition and night condition. So there is a complex object detection, so complex AI model involves. That AI model in combination of the object detection, classification, and the sensor, and continuously it is taking the input from the situation and predicting or acting like this. Then second is the image segmentation. That is very important. So when there is a two-person is coming, so the model can identify, okay, there is a two-person. If the one person is can one person, there is a some suppose the signal is there, signal is red. So that every time the self-driving car getting the as a small video, converting into the frame, and quickly analysis and then acting. So it's a very complicated system, but the system is working is very good into all the first world country. It's not working in the India, or we don't have any this self-driving car available in the India so far. The third one is the lane detection. So that still we have available in India. So if you use any kind of ADAS technology in the current upcoming car or current recently car, so all this the ADAS technology can detect the lane. So that is in the lane detection also, it's a computer vision technology generally used, either object detection or classification or combination of both. Then sensor data. So sensor data, as we discussed, so in the car is now the car is running a lot of sensor. So some sensor is taking data from the inbuilt of the. So what are the key component from cars? It is taking the tire pressure monitoring. It is taking the speed. It is taking the steering. Continuous taking the feedback. and that data basically generally put into the cloud, and they're processing the data and giving the feedback. So like the sensor data that I have already discussed. Okay, so competitive market in the current automobile vehicle. So the major player which we have discussed currently, all the Tesla or the Google or Uber, they are working on the self-driving car. And the market trend is basically slowly we are moving from the traditional or the electric. So how it will move. So currently we have a car is based on mechanical and electrical, then slowly move into the electric car, and then slowly will move into the self-drive car. But the major problem here is the regulatory and the safety. So when you're moving into the completely into the self-driving car, so that algorithm or that car is what, so we have to check this car is maintaining all the regulation of the current so which country it is running, that country regulation, that country traffic rules. So all this data you have to put, and you have to retain out those model, or we have to inbuild those information to the self-driving car. So what is the competitive landscape? A major player who are working on it. What is the market trend? Market trend is coming. We're moving into the electric car and the self-driving car. And third one is the regulatory challenges. So when we are moving into the electric car or the self-driving car, what are the regulatory things so that we have to also incorporate it into this kind of car? So self-driving car company. Currently, the major is the Tesla, and then the Omeo is basically Google research, but it didn't come market yet. And the lot of other company like the cruise automation, so they are doing the some automation technology, but still it is not into the market, but they are working into the self-driving car. They are couple of models they are trying to implement in the small thing like the Uber. They are trying to implement these things also. So case studies and the pilot project. So initially, the Google started the first case study in the machine learning self-driving car, but it was not successful. Still, it is in under research. But now the Tesla come up, and that. So Tesla's this slide is a little old. So we have done the testing into the urban environment. We have done the testing into the highway environment, and the Tesla is fully running into the US and Europe countries, and it's available into the retail market also. So if you want to any kind of Tesla car, you can get the Tesla, and it is running into the environment. Then what are the current challenges, or what are the key challenges we are facing, or we are going to face for the implementing the self-driving car? One is the technology limitation. Still, we don't have a 100%. So we don't have any algorithm which will give the 100% result. So all this algorithm we have to tweaked based on the our demand. So suppose when we are creating the object detection algorithm, we have to tweak like if the false positive is high, that is fine, but the false negative should be 0. So the false positive high means suppose there is a no object, but somehow the algorithm are missing detected is the object and put a break, that is fine. But the other way, the false negative. So there is an object, and the model is not able to identify there is an object, and there is accident happens. So like this, all the machine learning algorithm which we develop and put into the production in any kind of industry, right, in the automation industry or in the drug discovery or the healthcare industry, generally based on the business requirement, we tweak the algorithm, and either we work into the true positive or the sorry, false positive and the false negative part. So sometimes false positive is fine, sometimes false positive is not fine, sometimes false negative is fine, false negative is not fine. So based on that generally it is. Then lot of regulatory and ethical things. So when you are running or driving, or when you are inviting any the self-driving car, so that car should be fully regulated. All the machine learning algorithm which are um, deploying that algorithms should be pass through the AI governance board. So a lot of regulatory and ethical practices required, and still this is the actually challenges to implement any kind of self-driving car into a lot of countries. Currently running is the US and some countries, UK, some countries, but still a lot of countries is facing, because still there is a challenge to implement this regulatory and ethical practice. And then public acceptance. So still we are talking about the electric car. So there is a lot of issue. The first, as we said, the battery management. So suppose I'm going to from A city to B city, from if I'm going to from A place to B place in the same city regularly, then is fine, because when I'm going out, before going out, my car is fully charged, and when I'm going to the office, in office we have a charger, again we have put the charge and I'm coming back. But if I'm going to from A city to B city, we don't know where we'll get the charging station. So if you get the charging station currently, when you're putting the petrol or diesel, it is taking just 1 or 2 minutes to putting the petrol, and the car is a full tank. But when we are putting the charger, it will take 30 minutes to 45 minutes. So there is a lot of wait time is involved. So in highway, so we have to put a lot of charging station. We have to improve the charging station. I hope the previous speaker, he spoke about the wireless charging, those things. So those things is required for the future improvement. So the public acceptance is still not there in the still is a challenging for the self-driving car. So what are the feature scope you are checking? The feature scope is basically integrated with the smart grid. So as I mentioned, in the charging station is a key factor. So basically all the smart grid, all the petrol station we have to put in the charge. Second is the advancement of the battery technology. Still our battery is not that much. Still we are using lithium based battery for the charging purpose. So we need a better battery technology, so that if we charge one time, battery can go 600, 700 or 1,000 kilometers. So that we need improvement. Also we have to think so that battery can charge automatically when you're driving. So battery can just, we have a hybrid technology available, but that hybrid technology is just for the small backup of the car, but it will not for the full. So when you are driving, the battery will automatically charge, and that battery again you can drive. So these technology we need. Then, as I mentioned, the ethical implementation. So what about the ethical aspect or the AI governance aspect? So that the scope. So you have to work a lot into the ethical. So how we are accepting, how you will accept this kind of technology? Is it the fully regulated? Is it the fully auditable? And is it fully safety or not? And then long-term impact. So when you are when you are taking one electric vehicle or the self-drive car, so that is 15 or 20 lakhs. But when you are changing the battery, the battery cost will come 7 to 8 lakhs, depends on the which car you are taking. So the long-term impact. So what will be the long-term impact? So that all those things we need to do the proper research. So those, I feel there is a lot of scope to improvement for the any kind of self-driving or electric car. So next, in the technology point of view, what we are thinking the next, what will be the next technology? So still we are in the GenAI. GenAI basically large language model. So large language model is a very successful project. So OpenAI has published, and a lot of companies are using this large language model. Also it is available for the one-to-one customer also you can take. And this large language model is totally understand whatever the human is speaking, that speaking they can convert into the text, and they can analyze this text, and they can give the answer back also. The next what we are thinking, it will come the AGI. So still the first AGI research, the OpenAI started the research. AGI full form is basically artificial general intelligence, where the machine learning model or the GenAI model can act like a human. So still in the machine learning model, we don't have any kind of uh, feelings available. Like suppose all this model or whatever the algorithm you are talking, it's based on the data, and that data, basically from the data, basically they try to understand the pattern. So if it is false any pattern, then it can act and it can react. But if it is not following any pattern, but still its a case is a real, right? So these kind of thing, these kind of cases, still we have a error. So that's why you have all this the machine learning model. We have a 99% accuracy, 98% accuracy. But we are thinking when the AGI will come, that time it will maybe it will work on 99.999%, where the error margin is will be the very less. Next is the quantum computing, because all these heavy model, if you run the any LLM model, we need a huge GPU. So you have to run any, if you run any LLM model, you need a in Databricks basically double a cluster. So that is in 400 GB GPU required to train this model, fine tune this model, and deploy this model. So there is a scope we can work on the quantum. So quantum, where the same model we can put into the 1x format, or any different format where the model size will be very less and we can feed into the small device. And from, if you put this device or chip into the current thing, so the same model, huge model, can put into the device and that model can work. So these quantum level things also we need a, I think it's a technological advance will come. So the when the quantum machine learning will come, still we are not into that in the scenario. Okay, so second is the social impact or in the in AI. So my understanding, so everybody is thinking, okay, so now AI is tracking and there will be the job impact. There will be not job impact. AI basically it's a just a helper or is an assistant. So if you can use as an assistant, it will help you to give you the better performance, but it will not take any job or it will not replace any human. Ethical and legal issue already have discussed. The first is the ethical, then policy and regulation, and the safety standards. So all those three things we have to work when we're putting into any self-driving car, any machine learning solution into the market where the human life is involved. So three things is the main ethical and the policy and regulation in the country and the safety. So all this self-driving car is 100% safety or not, that we don't know. So those thing is challenges and it's a issue, so that we have to work on it in future. So I have only those. If you have any question, I'm happy to take, but just a overview. So I didn't go through any deep dive, any algorithm, nothing, just a overview of currently where you are and what are the algorithm you are using for the self-driving car, and how the automobile is working, how the AI can helping or AI can benefiting the automobile industry. So that I little bit talked about. Any question? I think now is the coffee time, so everybody is silent. So Minal, I have done. So I think there is a no question. So then I can close it.
Thank you, sir.
Yeah. Thank you, Kuzbi.
Thank you, sir. Thank you.
Yeah. Bye.